Hello everyone. In this video we're going to take a look at another problem involving the combined gas law. We're told that a 0.500 liter gas sample at STP is compressed to a volume of 0.300 liters and the temperature is increased to 35.0 degrees Celsius, and we want to find the new pressure of the gas in pascals. So as in the examples that we looked at in the previous video, we're dealing here with the properties of a gas being changed, which indicates that we want to use the combined gas law, and we have quantitative information. We're looking to find a numerical value, so we want to use the second version that we discussed. P1 V1 over T1 equals P2 V2 over T2. And as we did in the previous problem, let's write down all the values we have. So in the initial conditions, we have the volume is 0.500 liters, and we need to be careful here. Even though the temperature and pressure aren't spelled out for us, we are told that the gas sample was initially at STP, or standard temperature and pressure. And remember that standard temperature and pressure is a temperature of 0 degrees Celsius and a pressure of 1.00 atmospheres. One thing to think about, just as with the ideal gas law, our temperatures need to be in kelvins, and we know that to get temperature in kelvins, you add 273 to the temperature in degrees Celsius, so T1 equals 273 kelvins. We're also going to need to think about our pressure units later on, here where you have our pressure P1 written down in atmospheres, and we want to get our new pressure P2 in pascals, but we can deal with that conversion at the end of the problem. If we look at what we know about the second situation, we have the volume is 0.300 liters. Our temperature T2 is 35.0 degrees C, but again we need that in kelvins, so we add 273, and that gives us a temperature of 308 kelvins, and then P2 is what we're trying to find. And so if we look at the combined gas law, we're looking to find P2. One way to go about this is to solve for P2 algebraically first. So we can multiply by T2, divide by V2 on both sides. On the right, the V2's cancel, the T2's cancel, and so now we have P2 by itself. So P2 equals P1 V1 T2 over V2 T1. We can now plug in all those values that we have. We have 1.00 atmospheres times 0.500 liters times 308 kelvins, all over 0.300 liters times 273 kelvins. If we look at our units, liters over liters cancels, kelvins over kelvins cancels. And so right now our answer for P2 would be in atmospheres, but the question is asked for this pressure in pascals. Remember that the conversion factors for the various pressure units will be given to you on the test. And if we look up the conversion between atmospheres and pascals, 1 atmosphere is 1.01325 times 10 to the 6 pascals. Sorry, times 10 to the 5 pascals, I should say. And so then atmospheres would cancel with atmospheres. We'd be left with pascals, which is the unit that we've been asked for. And if we plug that all in, we can see from the values that we have that we should have 3 significant figures in our final answer. And the easiest way to express this is in scientific notation as 1.91 times 10 to the 5th pascals.